In this video, I'm planning to explain application of the second derivative. One of the application of the second derivative is concavity. Here, when the figure is increasing in this form, and when the curve bottom part looks down and the open part looks up, this is concave up figure, it is called. And this concave, if it is look down, it is concave down, it's going to be. And how to understand it's concave up and concave down? Here it is written, if the second derivative is greater than 0, it is concave up. Here, if the second derivative is greater than 0, concave up. Second derivative is less than 0, it is going to be concave down. Here we know these basic functions. That's why it's easy for understanding for us to it's greater than 0 or less than 0. Normally this function is parabolic function and it's looking down. It's going to be something like this. That's why this function is going to be concave down. And I want to prove this one firstly. And this is cubic function, and the graph of the cubic function, it's like this. And it means that sometimes it is concave down, sometimes it is concave up. This is the point, and we are going to call this point also inflection point. Later we are going to explain that one. Okay, to understand where the function is concave up or concave down, let's firstly find the second derivative. F derivative x is going to be equal to 9 minus 2x, it's going to be, and f second derivative x is going to be equal to minus 2. F second derivative x, as you see, is less than 0, which means function is concave down. Okay, the second one is x cube. X cube first derivative, it's going to be equal to 3x square, and f second derivative x, it's going to be equal to 6x. Here the problem is we didn't find a number like minus 2. This will be sometimes positive, sometimes negative. How to understand that one? Sometimes positive, sometimes negative. 6x, when it is equal to 0, we will find the root of it. So when x is equal to 0, 6x will be equal to 0, and this is the critical point for us. So when we draw, as always we are doing, when we have when we need to understand positiveness and negativeness, we are drawing this table. And here minus infinity, it's going to be f second derivative x is when the values are less than 0, it's going to be negative. When the values are greater than 0, it's going to be positive. This is the table of f second derivative. With respect to this table, when the function is f second derivative x, 6x negative, it means that our function is concave down, and when the function is positive, second derivative is, when the second derivative is positive, it means our main function, which is fx, here it should be fx is concave up, it's going to be. And I draw the figures before to see how they are and to analyze that one. Here I'm going to explain first the small x cube figure. As you see here, function is concave down here till 0, and x is equal to 0. You know it's changing its value, and 0 is the critical point for us, and we are going to call inflection point. From here, as you see, it's concave down firstly, and the figure it was like this, then it was like that, and after 0, the x is equal to 0 I'm talking about, function is becoming concave up. And for the second one, here especially I see the 9 minus x square, and as you see, always function is concave down. We don't have concave up part here, and also here the solution shows the same thing to us. Okay, here the name of that critical point, I said that's going to be inflection point. and from concave up to down or down to up, when we change the point, it is called inflection point. And here, as you see, the concave up and concave down does not exist in some conditions. Why it is not existing here or here? Let me explain. Because the second derivative is not defined. The third derivative, if you remember, the first derivative is not defined for these functions. So if it is not defined, it is not possible to find the second derivative also. Here, as you see, this is the corner point and this is vertical tangent, if you remember. But for these points, the first derivative is possible, so we can define the first derivative, then we can find the second derivative. Okay. Here, the intervals of concavity and inflection points we are going to find. Firstly, we are going to find first derivative, then second derivative. I'm finding the first derivative. F derivative x is equal to 1 over 2 4x cubed minus 4 times 3x squared plus 9 times 2x minus 7 plus 0 is going to be f second derivative x is going to be equal to, here if you simplify 4 and 2, this is going to be 2. 2 times 3x squared. This is going to be 12 minus 12 times 2x and plus 9 times 2 is equal to 18. X derivative is equal to 1 and minus 7 derivative is going to be equal to 0. That's why it's not written. So f second derivative x is equal to 6x squared minus 24x plus 18 is going to be. To understand the inflection point, we are going to find, to understand the inflection point, we should say the second derivative is equal to 0. We should write x squared, 6x squared minus 24x plus 18 is equal to 0. When the second derivative is equal to 0, if you remember, this gives us the inflection point. 6 seems is the common factor here, that's why x squared minus 4x plus 3, it's going to be equal to 0. Then when you multiply two numbers, the result is 0. One of them must be 0. 6 is not 0. X squared minus 4x plus 3 must be 0. Then x minus 3 and minus 1. We have x is equal to 3 and x is equal to 1 is the inflection point we are going to find. And of course we are going to try to understand positiveness and negativeness of the inflection point, this second derivative, to understand when the second derivative is positive. If you remember, it's concave up. When the second derivative is negative, it is concave down. We said 1 and 3, this is the critical point. Then fx is equal to f second derivative x is, this is the f second derivative x, the sign is plus, so it's going to be plus, minus and plus. This side is minus infinity and this side is going to be plus infinity, if you remember. This is the table for the f second derivative. Then if f second derivative is like this, fx, it's going to be concave up here, concave down here, and concave up here again. Okay, next question. Here at this question, already inflection point given. Here at x is equal to 1, it means that we have inflection point. So it means that all this question means that f second derivative x is equal to 1, f second derivative 1 is going to be equal to 0. And second part in this question, fx, if it's equal to y, and this ordered pairs 1 and 3, if it is written like x and y, it means that x and fx it's going to be, which means 1 and f1, and that's equal to 1 and 3 is going to be. So f1 is equal to 3 is going to be. So we have two information. One of them, f second derivative 1 is equal to 0. The second one, f1 is equal to 3. These are enough to find to a and b. Okay, first let's start with the f second derivative. F second derivative x is equal to 3x squared plus 2ax plus b is going to be f second derivative 1 is equal to 1 times, pardon, this is the first derivative, I made a mistake. This is the first derivative, and I'm going to find the second derivative. F second derivative x is equal to 6x plus 2a, it's going to be. And if f second derivative x is equal to 6x plus 2a, f second derivative 1 is going to be equal to 6 times 1 plus 2a. F second derivative 1 is equal to 0, so this means that 6 plus 2a is equal to 0, and 2a is equal to minus 6, a is equal to minus 3. It's going to be, this is the a value, and with respect to this given information we can easily find the b value, because I know that f1 is equal to 3. So f1 is equal to 1 cube plus a times 1 square plus b. A is equal to, sorry, I forgot to write here, a was equal to minus 3, we found minus 3 times 1 square, b times 1 plus 3 it was, and f1 is equal to, we know that it's equal to 3 is equal to 1 minus 3 plus b plus 3, and b is going to be equal to, here 3 and 3 we simplified, b is going to be equal to 2.